Hi everyone, this is the Multimodal AI workshop. Here's some links. There's a link to the Hack Invaders GitHub where you can find readmes for all of the workshops, including this one. And here's a link to the slides. If you don't want to have to type all this out, it's also linked in the readme for Multimodal AI in the GitHub. So you can go to the GitHub, go to the readme, and click on the link there. So here's the agenda for today. We're going to first go over what is multimodal AI, why it matters now, how it works under the hood, not like all the math stuff, but more of like a high level overview of like how these things work. Then I'm going to go over a live code demo and show you how to set up a quick like receipt reader where like you give it an image and it gets you like all the info from the receipt. And then I'll do some wrap up and next steps. So first off, what is multimodal AI? Multimodal AI is essentially AI that can take in multiple types of data. Multimodal just means like many different types of data, as the modality is just a type of data. So a multimodal AI is AI that can take in text, images, audio, video, and essentially, it handles all of them together. So you can get like text, it can output an image. You can get audio, output a video, etc. Essentially, it's an AI that can input any one of the modalities and output any one of the modalities. And you've also already probably used this. Sometimes, when you want to send AI and maybe translate something, you would take a picture of something and ask AI like, oh, translate it, or you want to upload a picture, ask what is this. Also sometimes, if you've used OpenAI's like Sora, which recently got sunsetted unfortunately, but if you use like Nano Banana or any of those image generation models, those are also multimodal. You tell it a description of what to make, and then it generates image based off what the prompt you gave it. Also, there's a lot of voice mode agents, for example, that allow you to talk to it, like it takes in the voice, it maybe translates into text, and then it feeds back voice back to you. So voice to voice is also, different modalities, voice to text to voice. The key point is that even though there's been like image classifiers and like single modality things that have existed, the new thing is that this one model can reason across all modalities. It's not just like, you take an image and then it kind of like classifies the image, or like you input text and get text. The new novel thing here is that you can input text and get something out that's completely different. And why now? So there's three big things that have changed that like brought the proliferation of lots of like good multimodal AIs. Number one, transformers. Transformers are essentially an architecture that was created a while ago. There's a paper about it that you definitely should read. It's called like Attention is All You Need. But essentially, transformers allow you to give attention to certain, like, for text essentially allows you to give attention to certain words. So like, for example, if you were talking about like a river bank versus like a money bank, transformers allow it to kind of figure out like what the word bank really means. Is it like a river bank? Is it like the money bank, etc. And so transformers essentially in multimodal, we'll go over this later, but essentially allows it to kind of match things together, and I'll explain more of that data. Paired data sets is also a huge thing. Like the creation of Weebly, which is like tons and tons of images that were like a data set of images that was created, and all the web data that was scraped essentially helped us train these models, so they got so good at multimodal things. And also cheaper compute, with NVIDIA always coming out with better and better AI chips. We can finally afford, or those big companies like OpenAI and Anthropic can afford to train one giant model that can understand all modalities. So right now is a really good time. And here's just some examples of real world apps that actually are multimodal. You can like read through the list, but I'll go over some really cool ones in my opinion. I think vision assistance is really cool. That if you imagine like you had this like meta glasses like that can like see the world, and it essentially feeds like what you are looking at to you in voice to you. So blind users are able to figure out what's around them. Another really cool one that I think of that you may experience is self-driving. If you have like a Tesla with self-driving, or I've ridden in a Waymo, that is multimodal. It uses sensor data, maybe camera data, etc., and uses that to actually drive the car. And I think the other ones are also in real use, but I think that personally self-driving and vision assistance are some of the coolest applications. So here's more about how it actually works. Multimodal AI works by transforming everything into an embedding. So you can think of, so there's this big in this, like in the AI world, there's this idea of a latent space. You can think of a latent space as essentially like a space with like a ton of dimensions. We only can think of 3 dimensions, so let's just think of like a 3-dimensional space, but just know that there's a lot more dimensions. And essentially, when you embed things, similar things get embedded closer to each other. So you can think this is a 2D embedding space actually, and you can see the dog photo and the word dog, the embeddings of the dog photo, the embeddings of the word dog, golden retriever, end up in this like similar space. Let's just say it's over on the left side. And say I have math things like algebra, I have a picture of math notes, that gets embedded, in a different area. So if I were to like, for example, like give input to like this embeddings into the model, it would first translate it into this vector embedding in this high dimensional space. And they could run some comparisons. Oh, like which kind of space am I in? Am I like closer to the math node space or am I closer to the dog node space? So for example, if I inputted a cat, I'd probably get something that's not identically near the dog space, but similar in like the animal realm, you can think of it. Whereas it would be probably pretty far away from the math area because a cat doesn't really relate to math. And essentially, transformers are able to kind of help match these different vectors together, and so you can get like similar data. So if I have a receipt, for example, and I tell it to, extract the total amount paid, the transformer's able to figure out like, oh, like in this receipt, in this embedding, I got to look for, the total, and that's how it figures that out. So here's how just for images are processed. So first the image gets transformed down into a smaller grid of squares. Each patch becomes a vector in the embedding. And if you were attaching a prompt to this image, which is what we're doing in our demo, the text and the image goes into the same transformer. And essentially, as I explained before, that with the text and image kind of in the same like prompt into the same transformer is able to figure out like what are the similarities and kind of match in that latent space, which is how you're able to get an actual relevant answer. So now here's a live code demo that I'm going to show. But first, I want you guys to you're gonna need to get an API key for Gemini API. It should be free. You don't need to get a billing account. Essentially, you just go to the website and sign into Google and then click Create API Key, and it should be a pretty straightforward process. Just make sure that you don't actually need to create a billing account. The API key, it should be free. And I'm going to go over the demo now. So here's the demo. And so before you get started in any coding, let's get our environment set up. So the first thing you want to do is you want to create a .env file. This is where you are going to put your API key. And essentially, the API key is something that normally it's a build thing. Just we're really very fortunate in this, like that Google's offering it for free for now. But normally, you don't want to share this key with anybody else. It's like a secret for you that allows you to call the Gemini API, because normally this costs money. So you want to keep this secret. And so the way of not putting it into your actual programs is you want to load it into the environment that your code is being run in. And a way that we can do that is with .env. So .env is essentially a package that allows you to put all of these like secret variables in a file called .env, and we can use this library to load this .env file. So I already have my key in my .env, and I'm not going to show it. So what you're going to do is just create this .env file. I'll do a .env.example, just so you see what you do. So you create a .env.example, and you're going to put in Gemini _API _key in all caps is equal to, and then you're going to paste your actual Gemini key here. So your Gemini key. And as I said, my .env already has my actual Gemini key, and I'm not going to show that because it's my key, and I'm going to get rid of this. But you just want to create the .env. And after that, another thing that we want to do is create a Python environment. So if you don't have Python installed on your computer, make sure to go ahead and Google how to install Python. I already have Python installed. But something that we're going to do here is create a virtual environment in Python. And the reason why we need to create a virtual environment is because your computer has like one global Python installation. And when you install packages into it without a virtual environment, you're essentially installing a ton of global packages. And if you have other projects that use those packages, like sometimes the packages will conflict. Like for example, maybe this receipt reader needs a newer version of a package, but my other project requires an older version. And essentially, installing all of them into the global space just causes a lot of conflicts and a lot of headaches. So essentially, what a virtual environment does is creates this little sandbox for my own project. Essentially, it isolates the packages in my own virtual environment, so it essentially prevents conflicts with other projects. And it's generally best practice to do a virtual environment whenever you're doing a Python project. So the way you want to do that, I'm on Mac, so I do Python 3-m venv. This is the name of the venv is creating a virtual environment, and then later it's the name of the virtual environment. So I'm gonna call it venv just to be simple. And you can see it created a venv folder, and that is our virtual environment. And then how you activate it is you want to do source venv /bin/activate. And as you can see, you know your environment is activated, but if you see these little parentheses with venv inside of them, that means I'm currently in the virtual environment. And the way you exit the virtual environment is you do deactivate. And there you go. You can see the parentheses exited. So I'm going to go ahead and go back into the virtual environment because I need to install some packages. And now that we're in the virtual environment, I'm going to go ahead and now install my packages. So the packages we'll need, I put them up here in the comment, is we're going to need Google Gen AI and Python.env. Google.-Gen-AI is just so we can use the Gemini API, and Python.env, as I said, is so we can load the .env. So I'm going to install them. And while they're installing, I'll go ahead and start explaining the code. The first thing I do when breaking down code to read is look at the imports. So let me go through all these imports real quick. So we need to import JSON because when we deal with web requests, because that's what we're doing, we're making a request to the Gemini API. All the response format is in JSON, so we need the JSON library in order to parse the data and actually get data that we can use. We need the sys, import sys, because essentially how this program is going to work is you're going to pass in an argument into the terminal of like what image you want to read from, and this essentially allows us to extract that path. We need pathlib import path in order because you're going to provide the path to the image you are trying to read into the program, and path essentially just lets the program read from that path and grab that image. As I already explained, for load.env essentially just loads the environment in. And then we need Google Gen AI and types in order to do multimodality with the Gemini API, and we need the Gemini API. So let me walk through the code here. So first we need to load .env. As I said before, it loads our Gemini API key from .env into the environment that this program is running in, and client is equal to genai.client instantiates our Google Gemini client. We have this function here, read receipt. Essentially, you pass in a path to an image, and it responds with the Python dictionary of structured data of what it reads from that image. So you can see, so first of all, we need to grab the bytes from the image because the Google Gemini API takes in the image as bytes. And then response is equal to client.models.generate content. This is essentially how we call the Gemini API. It's essentially we're going to send it a request with a prompt, and we're going to receive some response. So we pass it in some parameters. Model is equal to Gemini 2.5 flash. That's which AI model we're using. Content is what we're going to send as a prompt. And as I said before in the slides, we're going to be sending a text prompt here, and we're also going to be sending an image prompt as well. And those are going to be interleaved in the same prompt and go into the same transformer so that the AI model can kind of figure out what we're looking for. So types.part.from bytes, data is equal to image bytes. MIME type is equal to image/JPEG. Essentially, what this is saying is that we are going to send these image bytes that we just read from this image path. And MIME type is image/JPEG. Essentially just tells it that the type of this image is a JPEG image. This is the prompt that we're sending in. And it's essentially that what we're going to try to send in is we're going to send in a picture of a receipt. And we want the AI model to figure out, what's the vendor, what's the date, what are the items, what's the total, and what currency is it in. So this is the prompt, and the next configuration we're going to say is that we're going to use types, and we're going to say that the generated content configuration is that our response should be the type of /JSON. So we want a JSON response, which is a form of structured data. JSON means JavaScript object notation. Essentially, it's just a nice way to format all of our data into a specific format, and you'll see when it gets printed. And we return JSON.loads. JSON.loads essentially just parses the response from the model into a Python dictionary, which then we can use, and this is return. And if name equals main, just if we are running this as the main program, result is equal to, we're going to call this function, and sys.argv is the first parameter we pass in the command line, and I'll show that to you in a second. And essentially all we're going to do is print out json.dumps with indent2, just prints the JSON object in a really, really nice way. And so we'll be able to see like exactly like what the model returned. So I'm going to go ahead and run this, and we run it by calling Python the name of the file, receipt reader.py, and a path to our picture that we want to send. So I have a picture called receipt.jpg, and I'm going to put it in. And we're going to wait for the model to respond. Right now it's being sent to the model through the API, and then we're going to return. So I'm going to expand this. So this is what JSON object notation looks like, and you can see that in the image the vendor is rock, English, fish, and chips. You can see the date. We can see it extract these items that were purchased. This is the total and this is the currency. If I go look at the image itself, it looks pretty accurate. So essentially through multimodality, I was able to input an image with some text and get back out structured response. So later, if you wanted to create like a program to track all of your receipts or track your spending, you can just take pictures of all your receipts, put it into some program like this, and have it respond with structured data. And some extra things I wanted to note are that because we're kind of inputting an image and we have a prompt, sometimes things don't always go as we expect. I have a picture of a cat here, and I just want to show you what happens that if I happen to insert a cat, in which I'm asking, the model to extract a receipt, and assuming I put in a receipt. So I'm going to try putting in the cat. And you can see I got a response of null. Let's try again. This time I got an empty JSON. I got null again. So here I can see like sometimes, you don't always get what you want. Sometimes, if you have like a pipeline, and something went wrong and you didn't send an actual receipt. One thing that you have to deal with these like AI applications is you want to always have retries and be able to recover from failures. So ideally, you would catch all these cases and have retries. Maybe, the AI got something wrong. The image can be blurry. The image can be a cat. You never know. So it's always good to have safeguards on that. And so yeah, here's the full code. You can copy it if you need. And hope you enjoyed this workshop. Thank you so much.